Well, thank you very much. Thank you, Kai, for the invite and also for the great introduction by my colleague, so to say, on the topic on exposure and sound dose. I want to quickly like give a perspective on the challenges that we are facing when we look at like sound dose estimations on consumer electronic devices. Maybe one sentence for you as a background for Mimi Technologies. We are basically providing a hearing testing and hearing loss compensation technology for consumer electronic devices, for headphones. And therefore, we are very interested in like providing also like a healthy listening experience to our listeners, and we are very interested to learn about like these things and using sound dose as a metric to assess healthiness in terms of listening for the user. We will quickly look at the behavioral risks or review the risk factors to a healthy hearing, like based on new music listening. We will look at the interventions that are there that can like address the modifiable risk factors. And then we will go into limitations, the technical limitations that we just face when we are dealing with consumer audio devices and with all the unknowns that are there. And now we have some concluding thoughts from our side there. So the behavioral risk factors like associated, like I think maybe some of this is already like clear to you, but like a lot of young people actually at the risk of developing like music-induced or noise-induced hearing loss, or at least like putting themselves at a higher risk just by a matter of their listening behavior, by listening to loud music over extended periods of time. And WHO is also like addressing this on a regular basis, and like also saying that there's a large amount of young people that are actually affected of developing noise-induced or music-induced hearing loss. And the question is like, why is this? And there's obviously there's research around that try to understand why is this actually. And I think like the Metallica examples and the Rolling Stones examples, I think they already hinted in this direction. And probably also you're aware, like people like to listen to loud sounds, and it's interesting that even though they know also about the relation between like loud sound, loud noise, and hearing loss, they typically don't see themselves at risk. Also, like a lower like audio level is typically also like related to a loss in pleasure. So basically, also something that people want to avoid. So they want to like perceive like pleasure and like use music for leisure, basically. And also interesting is like the aspect of background noise, basically. So like as soon as there's background noise, people tend, like when they're listening with their headphones, they tend to like increase the volume. Just as a matter of fact, I guess all you are aware of this. And there's also like some numbers out there that say like once the background noise rises above like 65 decibels, people set their personal listening device, their audio level on their devices actually to a level that actually can on the longer term harm their hearing. So much for the risk factors, just as a review. Like on terms of intervention, like how can we motivate the people to modify their behavior actually, because this is what we are trying to get in the end. It's basically about raising awareness and understand the problem. And it's like one kind of measure for this is like sound dose, or using the communication of sound dose, of relating the user's hearing ability, practice and their typical listening experience to their actual or their presumed risk also of developing hearing loss, basically. And this one metric for this is sound dose, which we'll talk a little bit more about that one. On the aspect of background noise, although like ANC and active noise cancellation and these kind of technologies are like basically all around, they also like tend to like do or provide other risk factors, because if you go in the traffic with like this active noise cancelling, you will likely get also like in dangerous situations when you're not where you're not aware about the traffic anymore, where you're not aware about the people approaching you very fast. So this can also introduce other like risk factors other than like only hearing related. Interventions on a signal level, it's like one option is to limit the maximum volume. There are also regulations that says, okay, this is the maximum volume you can put on your device, basically, for the manufacturers. Another idea is also to reduce the maximum volume after a specific exposure taken, basically. Or other ideas are about modifying the dynamic range, so people automatically adapt their listening behavior just because of the changes that is applied to the music or the signals. The problem with the latter ones is that people will try to find a workaround on that one. We want to go a little bit deeper on this raising awareness and the sound dose aspect here. And the ITU, the H70, and also what is also referenced in the WHO is typically the sound allowance. So it's a number that says this amount of sound dose is leads to or a limit that is introduced over a week of time. And once this limit is exceeded, you are at a risk of developing additional hearing loss other than your hearing loss due to aging. How dose is basically calculated? It takes the sound pressure level, the A-weighted sound pressure level over a period of time, and accumulates this just over time. So time goes into this equation, and also the sound pressure itself. And there's also this reference that then this comes very much from the noise-induced hearing loss research, basically, is that this 40 hours of exposure with a level of 80 decibels leads to this 100% of allowed dose. So there's not, if you go beyond this level, you are at risk of developing additional hearing loss. And to get a little bit of a better feeling of how level and time affect the accumulated weekly allowance, we quickly look at here examples. So this was defined as the reference condition. So a level of 80 decibels over 40 hours in a week leads to this weekly allowance of 100%. If we lower this by 3 decibels to 77 decibels and look at the same period of time, this reduces the weekly allowance to a half. So basically, by lowering the level significantly, you reduced the weekly allowance or the accumulated dose by 50%, basically. And just to remind ourselves, 3 decibels is actually very, very little. It's just perceivable. And this is typically the exchange rate between time and volume that goes into the dose calculation concept. And if you're listening to a significant louder level, for example, here 90 decibels, and you only listen there for 2 hours, you also exceeded reached the 50% of your weekly allowance. So after that, there's only the additional 50% left for this week. And after this, following this concept, you are again at the point of increasing your risk for developing additional hearing loss. So we are in the consumer audio space, and we are looking, okay, where can we actually measure the metrics that we need to calculate and communicate sound dose? And ideally, we would measure this at that point, which is right at the end of all the signal processing, just at the eardrum, basically, the physical sound pressure. That would be ideal, but it's often not feasible, because we cannot often put microphones there and just extract the levels. So we have to deal with the technical limitations, which is typically when we are looking at the headphone case, measuring before the direct analog conversion. And then there are additional, this point of the signal chain is much more accessible, but it leaves out important components that come after that and that need to be estimated, basically. For example, the headphone and also the digital analog converter. This is a bit about how the dose is actually calculated. I'm not going too far on this. I just wanted to quickly highlight here. This is again the headphone, basically, that we are looking in a second a bit closer and see how much influence the headphone response only has on these metrics. So we are looking at 2 limitations: the headphones and also the playback level and the stimuli. This is also very interesting to look at when we are trying to calculate and estimate sound dose. So in terms of sound dose, there's also great work existing that also looked at this and tried to capture the influence introduced by the actual headphone response and on the sound dose. And this is just here a couple of like different headphone types were picked and were just compared according to their sensitivity, but also to their frequency dependent like transfer function. And we see quite a variation. We see like the headphone transfer functions that like produce significantly little or significantly less volume, for example, like this lower curve here, than like the majority of headphones, but also like the variance across frequencies quite large actually. And this is what we just see when we are talking about consumer audio devices. When we look at this like a bit more close and also relate this to those, we just brought an example here. We have now here like 4 headphones on the left side, and we again see the headphone frequency response. There again we see like very crazy like frequency responses, especially like that one here, the orange curve here. These were not, these were also aligned, so we don't know the absolute sensitivity, but they were just aligned about the 1K, just to make the comparison a bit more, make them more comparable basically. And when we calculate the sound dose, just in this example, for these different headphones that we have here, and there are also additional ones included, we see quite a wide variety of dose that we calculate following this approach, and like just considering the variety that is introduced by the headphones. So it goes from, I don't know, like 5% here to above 20%, just because of the different frequency behavior of the headphones that are used basically. So another thing that is also important, so we typically don't know the sensitivity, the absolute sensitivity of the headphone that the people are using with their smartphones, with their devices. So we as said back before, we can like estimate the dose at the earlier point in the signal chain, but a lot of things we have to guess. So we also asked the question like, okay, like if we don't know a lot about like the later parts of the signal chain, if we would know like these kind of parts, would this give us like any indication of the absolute level that the people are actually listening to? So if we would know that the headphone has a certain sensitivity, does this tell us anything about like their listening level that they are applying when they are listening to music? And we approached this in a short study here, where we asked the user to like set, we played back a musical stimuli. We asked the user, this was in a remote setup, we asked the user to set the level to the preferred kind of level that they like to listen to. And then this level was reduced again by 20 decibels after this step. And then the participants will then ask again to set the level for like additional stimuli to the same level that they just like had before, and just like compare what they set initially to what they set it afterwards. And the instruction was like, set it to the level that you would like to listen to now. And we also included the same stimuli just to be comparable, to see whether this concept of one playback level is actually one thing that we can follow, and it is also worth factoring into the dose estimations. And what we then see here is basically, this is like data, like every box plot is one participant. We have the 80 decibels line, the assumed 80 decibels line here. This was the line where the initial level was set to. And then we have the 60 decibels line. This is where the level was set to after like this initial set. And then the box plot basically tells us where the people set their listening levels to for the different like stimuli. And what we see is like, it's a quite diverse range of levels, like ranging easily 10 decibels or more in the same kind of listening setup with the same headphones, and even like the same musical content. So this concept of people are listening at the same volume, even if the background does not change, is also very, very hard to follow here. And so we have to see how much sense does it make to assume that people are listening at the same level if we even in a very like fixed environment we cannot see, we cannot prove this basically. And this comes basically also back to all research on this question of most comfortable level, which is also like where you also see typically a range, and where people adapt their preferred listening level very, very dependent on also the stimuli itself. So it also puts a question on how much accuracy can we actually get on calculating sound dose and on headphones in the consumer audio electronic devices. It also, and this are also this aspects in the talk just before that one, the audio that is consumed via the headphones is just one part of the story, obviously. The exposure to noise and sound outside this use case can be significantly higher than what is consumed via the headphones. And this needs to be factored in. Like if we want to make the user aware of how much noise they're actually exposing themselves to, there's the headphone part, there's the media part, but there's also all occupational and environmental noise. And luckily, like with in the former talk, it was the hearing aids. Here, like another research looked at how smart watches can actually be used for that, and there seem to be actually okay in terms of accuracy to estimate also the levels that people are exposed to over a day. And then there are also questionnaires to try to estimate the annual noise exposure you are exposed to. So there are different like ways, and the problem that they are trying to solve is the same, like getting a better like handle on how much sound you are exposed to. And there are certain ways for example, in the headphone where you can estimate something. Then if you have a smartwatch, you can estimate also something. If you are a hearing aid user, there's also a measure or a means where you can estimate something. So it's parts that bring the whole story together, basically. But then in the end, like, it's also important to raise the initial question again, actually, what is it all about? What is the purpose of all this, actually? And for us, it's really coming back to, okay, actually, it's about raising awareness about that topic. It's not about like giving the exact concrete and accurate number to a user and say like, here you are fine and here this is safe and like this is unsafe, because all this research comes from noise exposure, not from music exposure. We don't know like how good or bad this actually translates and whether this can be translated directly. So it's much more important to make the user aware, make the people aware about their listening behavior and how this can affect actually their long-term health of their ears, of the hearing. And try and make them engage with this. And the cool thing is we can like jump on the trend that is actually like that we see, which is like tracking all kinds of health data. So sleeping, walking, breathing, like people are tracking everything with their devices. We are all aware of that. And I think like having a good means and make it enjoyable to track also your hearing health data is something that is one option how we can win more people for engaging with their listening habits. I think this is the for us the most important thing. And like also one initial or additional initiative that we are also like pushing forward within MIMI. This is with the Johns Hopkins Cochlear Center for Hearing and Public Health. We have launched an initiative basically that is exactly about this topic. It's exactly about raising awareness about your hearing. And the idea is that everybody of us has a hearing number. And your hearing number is basically what is used here is the PTA4, so the pure tone average across the 4 frequencies from your absolute thresholds. And the idea is that people know their hearing number just as they know their blood pressure or their other numbers that they know about their blood type, about their health, and that they have an easier time to interact and to engage and to understand and to react also to changes in their hearing number. And I think this initiative is one path in the right direction to raise more awareness for hearing health in general and make it more feasible for users. Thank you for listening.